I actually gave this presentation some time ago, and uh, anyway, the state asked me to come back and do it when I offered this as a potential idea. I was hoping somebody else would have an idea on groundwater hydrology, but this is what you got. So thank you for listening to it. Um, just kind of as a background, in 2015, Woods Cross City was having some interesting um, issues. Um, And I'll get into those issues. I'll go back in a second, but some interesting issues with a whole bunch of houses in our community. Front porches were falling apart. Um, Here we have cracks that were, the size you could put your finger, or your child could put his finger through there, or rodents or whatever could get through. That one there's in the ceiling somewhere. And throughout, if you're in this house, you can see it just kind of creep down the wall. So in essence, the house is just breaking in half, and having to deal with that. Here's a picture of a door. Um, this door is now a good inch out of plumb. It's quite possible that this door doesn't open anymore. That's a problem if it's your front door, or a major door to your house. And here's one of my favorites. This one here kind of gives me still nightmares. This is the gas main. And as you can see, that gas main has a little bit of a pivot arm there. The gas company came in 2015 and put a bunch of these pivot arms on. But it already is getting to a point where it's starting to pull on the house. Another, 10 degrees, and that pivot arm will be vertical and potentially rip through the wall, or potentially shear. If that shears, that's a real big problem. This is one for Public Works. That curb and gutter used to be straight, and now, excuse me, and now it undulates, and that's difficult for the curb and gutter. You can usually kind of deal with that. The big concern that we have are the sewer, the storm drain, the water lines, other utilities underground that are potentially undulating as well. And what happens when all of a sudden the sewage or the stormwater doesn't flow through that pipe anymore. Here's one that actually did happen. This was a picture that was taken before this pipe sheared. So what's happening in this picture is, to the left is a well, and to the right is the pipe that goes underground out to the street. Well, that well is buried so deep in the ground that it's not subsiding, but everything at ground surface is subsiding. And it just takes a matter of time. Right there in that picture, it's almost 2 inches. A matter of time before something gives way, and you've got water squirting out inside your pump house. And that's actually what happened. So some of the things that I want to get to, that I want to talk about today, is just subsidence effects, what the groundwater level is involved with, and then some of the studies that not only Woods Cross City but also the state and others have done, flow diagrams with Great Salt Lake, potential possible saline intrusion, Great Salt Lake priorities, and some of the things that we're doing, and then some of the things that all of us as individuals can hopefully do to help with the problem that we're having. So the problem that we're having are these: potential structural damage. So far, Woods Cross City has spent a couple $1 million in lifting homes. That's not to say the amount of money that we've put towards lowering sewer manholes that are now poking a foot up out of the ground, and other utility repairs, and curb and gutter, storm drain, other repairs. Another issue, of course, is the natural gas company. I showed that photo of all those laterals. They went in, and I believe there are about 48 homes that they put those pivot arms on. They come in often and look at those again, hoping that there isn't one that's getting a little too close to shearing. Woods Cross City, as you all know, has a lot of petroleum companies around it. There are petroleum pipes all over in Woods Cross City that connect all the different refineries together. And so that's a problem if something were to shear there. I already mentioned water, sewer, storm drain. Railroads is another problem. Every year, Union Pacific Railroad comes in and lifts one of their crossings on 1500 South Street. It's just because it's settled a little bit. It's in a neighborhood where we've seen as much as 8 to 11 inches of drop in some of the adjacent homes. Bridges would be a problem. Thankfully, we haven't had too many of those in the area. And of course, roadway infrastructure, curb and gutter and such are issues there. So you ask, what's the cause of this subsidence? We found 3 causes. I'll just show you the slide. Number 1 is drought. So what happens is physically, there's less water going into the groundwater. And so the groundwater used to be in this particular neighborhood where we were having it used to be 4 feet down. When it was built in the late 90s, they put a land drain in to try and pull that water away from the houses. Well, when we started seeing these problems, we pulled the manholes on the land drain, and sure enough, the land drain was dry. No water at all in that. So it had dropped already from 4 feet down to at least, that 8 to 10 feet down where the land drain was installed. With further review and boreholes and other investigation, we found that the groundwater table has dropped a good 25 to 30 feet. And I've got a slide here coming up in a second that shows that. The second cause of this subsidence is the recharge area reduction. As we build our homes further and further up the mountainside, the recharge area that recharges the groundwater table is disappearing. That's obviously becoming a problem. And then, of course, groundwater pumping. As people pull the water out of the ground, there's less water there to be pumped out of the ground. Here's a picture that shows the groundwater levels. I don't know if you can really see that, but some of those wells along the Woods Cross, Centerville area, West Bountiful, some of those communities, some of them used to be artesian. Now they're 20 feet lower, 30 feet lower. There's one there, if you look at it close, it's about 50 feet lower that has occurred over the last couple decades. Well, 2 decades there shown on that. So back to 4th grade water cycles studies and education. If you will step back with me a few years for some of us. Here's the water cycle. The water rains up in the mountains, snow comes in the mountains, comes down through the valleys and the canyons, the rivers, and ultimately ends up in the Great Salt Lake. Here's kind of a blow up of what that looks like. You see that dotted line there, which is the groundwater table. Well, if you've got wells and such above or trying to get water above that groundwater table, you have to pump it out of the ground. If you're down below that groundwater table, the piezometric surface there shown, water just gushes out of the pipe. Kind of an interesting phenomenon. Woods Cross City used to have a lot of flowing wells. We don't anymore. So what happens next is that groundwater table drops. Flowing wells no longer flow. And then, you get pumping going on. That groundwater table changes even more. And one of the concerns that I'll talk about here in a second is the gradient of that line from the Great Salt Lake towards the well is negative compared to the gradient of the water and the hill slopes coming out of the mountains. And so, in essence, is there potential that the Great Salt Lake salts are coming back into the aquifer. And I'll talk about that in a second. One of the things that Woods Cross City did right out of the chute is we hired, it was South Dakota School of Mines to do what's called an INSAR study. We found out about this because Southern Utah's had some of these same issues. What they do is they take satellite imagery and they go out there and I won't get into the science of it, but they kind of try to figure out how much the ground has dropped. All those contour lines are in centimeters, and you can see if you were to zoom in there, there's a 5 and a 6. There's 2.5 inches during the period from 2005 to 2010. Those areas I tried to draw on where I-15 is, where Legacy Highway is. Those areas are coincidentally located fairly close to a lot of the wells in that area. The groundwater is high quality in that area, and so you see those areas where the ground, and this isn't groundwater, this is ground surface itself, has dropped those 6 centimeters in that 10-year period. Fast forward, here is a 1-year period, just a few years after that one. And you can only do this when the satellites have obtained this INSAR information. And so here's a 1-year period, and you can see some 6 centimeters in that area. So in 1 year, it dropped as much as it did the previous 10 years in that area. And they're not contiguous. There was a 5-year span between them. And then fast forward again to where we are today in 2017, in 2024, last year we hired this company to go in again. It's kind of interesting if you look right there on the well, let's see, it would be on the right-hand side. There's a whole bunch of contours. There's a big 10 in the middle and a black dot. Those contours and that black dot do not exist in the other INSAR images. And what that is a well that was drilled in that area, and the ground surface has subsided from that. So, like I said, there's three issues that are happening, but obviously pumping is one. Those contours span all the way from North Salt Lake on the south, all the way up into Centerville on the north, and so it impacts a very, very large area. Here's a cross section that the consultant did, and we'd have to go back to 5th grade math to figure out the conversion between centimeters and inches. But as you can see, some of those wells and such have dropped 16 centimeters, which is about 10 inches of just the ground surface have dropped. So we talked to a lot of other people, what's going on? Where is this happening? One of the things that I found interesting was a Sankey diagram of the Great Salt Lake. Here's all the water that comes into the Great Salt Lake. And I think this was a study that Jean had that she gave me a copy of with Kelsey's office. It shows the different contributory elements of the Great Salt Lake. You have the Bear River, Weber River, Jordan River. Then you got some other things down at the bottom. If you really look hard, there's something called groundwater, and it's shown at 75,000 acre feet. Just to excuse the pun, but a drop in the water compared to everything else that's out there. Recent studies have shown that number to be as much as 350. So comparatively speaking, groundwater is a major contributor to the Great Salt Lake. I didn't go to the efforts of redrawing the Sankey diagram, but that's what's there. As I mentioned before, we were concerned about saline intrusion. This is what saline intrusion, some of the stuff you have to look at. Salt isn't just sodium chloride you shake on your potatoes and eggs for breakfast. It's more than that. It's other things like calcium bromide and magnesium sulfate and all these different cations and anions. So you test for these different constituents, and most of them come into the total dissolved solids, the TDS, there at the bottom. So we are now starting to analyze these salts and TDS in our system. Frankly, I can't disclose some of the information, but we have seen a definite increase in salts in the groundwater table in that area. Here's one thing that I found interesting as I started talking to people about our concerns with Woods Cross City. There are several priorities, and you've heard a bunch of them at the top as it relates to water, getting water to the Great Salt Lake. One is threatened and endangered species. Another one's the brine shrimp industry. I've added the refineries on there. Another one is Great Salt Lake dust concerns. But in my conversations with other people in the state, there have been some other things that we've added as well, and they are groundwater management. If everybody pumps whatever they want out of the groundwater table drops. There has to be some management to that. Right now, it's just self-imposed. We hope not to get to a point where it's imposed by the state engineers. Another one is the saline intrusion I've talked about. Ground surface subsidence. Millions of dollars is being spent in ground surface subsidence right now. And it's something that needs to be curtailed at least, if not improved upon or ameliorated. And then water quality is a concern with the state as well. You know, what kind of water quality are we putting back underground, Mickey? Here's the continuing efforts of Woods Cross. We are continuing trying to peer up homes. There have been at least 20 homes that I saw that I was looking at on our GIS that have been peered. Pursuing grants and funding with the state. We are also pursuing a reuse plan. Our intent is to see if we can put some of that water back in the ground. If we can treat that water, or excuse me, not to put some of the water back in the ground. Our intent is to try and draw less water. So let me forward to this slide here. Those cities there on the top of that table are accounting for about 80% of the water that's being pumped out of the ground. Irrigation at the time of this study was accounting for about 3%. Most of it comes from the aquifer from the Weber River. But look there at the bottom, you see this industrial use. The refineries are using 17% of the water that come out of the ground there. They have been champions. They've been excellent to work with. They are of the mindset that if we do a reuse plan, they are willing to put that water, to use the reuse water in their cooling for the refineries, which would be a wonderful thing, 17% less water coming out of the ground. This is a figure that's been modified from our reuse plan. The recharge areas across the top, we need to do our best at getting the recharge area to charge again. What that means is buying properties, putting water on it, allowing it to percolate. I don't think we're going to slow down people building up there, but it'd be nice to get that. And then what we would do is we put it in the purple area down below into irrigation and to the refineries. So some personal efforts, I think this is the last slide, is to encourage water conservation. Always a good idea in the desert. Number 2, encourage on-site detention and retention. As MS4s, a lot of times cities just want to send it west, and there's a lot of push to just sending it west. It still needs to percolate in the ground, and it will get there west. We'll fill up the Great Salt Lake from the bottom up if we do it right. Keeping the groundwater clean, supporting recharge efforts, supporting reuse efforts if done appropriately. We're working with friends at Great Salt Lake on some of that. One thing that I put in here, a lot of times we shovel all of our snow out into the street. That could be a problem. If we put it on grass, on areas that can percolate that water in the groundwater table, that'd be helpful. Discourage elimination of the recharge areas, and then proper tree and plantings. I think that's about all that I've got time for. Do you have any questions for me?